All right, here's our bell work for the day. And there's your answers for the bell work. All right, here's our objective. I can find the lateral and total surface area of 3D objects. Oh, sounds interesting. So 3D objects, we're looking at prisms today, which is, I think it's on the worksheet for this game. So what you'll notice about prisms is that it's kind of like, I don't know, to say it's flat on the edges isn't always true, but for most of the ones we're going to be looking at, what you're going to do is you're going to look at a shape on two parts of the, we're going to pretend like this is, I think I can clean that up a little bit. We're going to pretend like I drew a very nice pentagon right here, okay? Yeah, no, we're pretending still. So, and what we're going to do here is, yeah, we're going to, so a prism like this is where it's named after the two sides that match, like this. So where this one is a pentagon and a pentagon like this, I would say it's a pentagonal prism. Now I haven't finished drawing it, of course. But then what you have is just straight edges like this, and you'll probably notice that around the sides of this you get just rectangles. So if the top were a rectangle, then it's a rectangular prism, and you could say, well, I don't really understand how the sides work. Well, it wouldn't matter which side you say is the sides or the top or bottom of that particular type of prism. But you can have octagonal prisms or nonagonal prisms or triangular prisms. So, and what we get sometimes is you're going to end up with like a circular, that's not circular. You're going to end up with a circular type prism like this. And there is a specific name for that, by the way. So that's not too bad.
How do you draw?
So, let's see if I can draw that better. That's not my worst. If I make them thick. Happy mistakes. All right. So this is not called a prism anymore because the top and bottom here is circular. That's a cylinder right here. Cylinder. Maybe it's AR. I feel like I should have a poster that says this. Cylinder. Oh, it is an E. There we go. Cylinder. Which is just really a circular prism like this. Okay. Now we got to be able to find the area of these types of objects. There are more types of objects. We're not really worried about that stuff. So what you're going to do is you'd find the area of the two edges, and then, well, once you have most of the shapes we're going to look at are regular, which means all their sides are equal, kind of like squares are regular parallelogram or quadrilateral, if you will. But that'll help us to find the area of these rectangles on the sides, okay? Now, just so you understand, these rectangles here on the sides, like this one and that one off the edge, this one and this one, I know it got kind of messy right there, but all those orange rectangles, that's considered the lateral area, which you're going to need to know for the assignment. Because they're going to say, what's the lateral area of this thing? Well, then you got to look at just the edges, the sides, I would say. And then the top and bottom, those are considered part of the actual full surface area of this shape, okay? And it's the same thing with the cylinder, right? This part that wraps around the cylinder is the lateral area. And then the top and bottom of the cylinder would be added on to the lateral area to find the total surface area. Copy the measurements to the net. So just so we understand what a net is, a net would be the two-dimensional shape. Like if you were to put this on like a piece of paper and then cut it out, you could actually fold it into, well, this is what we call a cylinder. So on this one, right, it says copy these measurements, okay, because we're going to need that. And yeah, this goes back to knowing the area of, knowing how to find the area of a circle and also rectangle, of course. So, and you can see if you were to fold these two circles up and down and then just wrap it with this rectangle, then you would have a cylinder, okay? So if you're ever wondering about how to make a cylinder, that's what you would do. Well, it says to copy the measurements on it. So we can see right here that the radius there of the circle is 4. And you can put on the other one if you'd like. So here's what we get is we got this rectangle. It's a 7. It doesn't say what the units is on that. But we would still need to find this length of that rectangle in order to find the lateral surface area, which we're going to need to do. Well, what is the length of this green length right here? As it turns out, it's the circumference of the circle. So to find that length, I would take, pi times 2 times the radius, and we know the radius is 4. And I'm just going to round this to the nearest tenth. Yeah, that's what it says, round to the nearest tenth. So I got pi times 2 times 4.
Wait,
So
up on the area for me.
yeah, finding the circumference here, well, it's going to wrap around, it's going to tell us that it wraps around that circle. That's the perimeter of that circle. So I got 8 pi, but I need the decimal, so I got 25. I changed it 25.13, so I'm just going to make that 25.1. And now I can find the area of the rectangle, which would be, 25.1 times 7. This would be the lateral area, by the way. Sometimes they just say it's LA, lateral area. So 25.1 times 7, I got 175. Maybe I should read that smaller. 175.7. So that is the lateral area, and you could say square units if you'd like. But to find the full surface area, I need the area of the circle here. So that area would be pi. Pi times the radius times the radius. So let's see what that is. Pi times 4. So that's 16 pi, but again, I want the decimal to the nearest tenth. I got 50.265, so I'm going to make that 50.3. We got 2 of those though, right? So I'm going to multiply that by 2. 50.3 times 2. That's now 100.6. Now, why did I multiply it by 2? It's because we got this second circle right here, okay? So the total surface area, we got the 100.6 square units, but we need to add the lateral surface area at 175.7 square units. And what do we get? There's a 3 and a 1, a 6 and a 7 and a 2. 276.3, I'll put square units. That would be the total surface area. So we do have the lateral surface area there. And then in black we got the total surface area. Here is a new shape. And yeah, we're going to copy these measurements. That's very generous that they gave us some of this action. Well, yeah, we got this shape, right? This is a prism, right? So the last example was a cylinder. This is a prism now. And we know that because it's not a circular base right here. This is a 6-sided shape, which is a hexagon. Hexagonal prism right here. And so, yeah, we got, that's why it's showing 6. Those should be rectangles, but squares will work, I guess. And then you got the hexagons as the base and the top. I call it the top and bottom, but whatever, okay? So we need to put these measurements on this, on the hexagon. Yeah, it's showing that it's important to know that's a bisector right there. What I really want you to know right now is that creates a 90-degree angle, which is really all we need for that. And I'll show you why here in a second. And that is a 6.9 units. That's a 9 right there. Okay. And then it shows kind of, and again, we get to assume that all these lengths are the same. So it's a regular hexagon. Yeah, I understand it is difficult to show a 3-dimensional shape in 2 dimensions. But yeah, it is tilted right here to show that it particularly that it's in the center of that hexagon. Going again, to the middle of it. The nice thing about this is we know that they're pretty much only going to give us regular shapes. So all of the lengths on the edges of the hexagon are going to be 8. And so the 9 right here is the height of this thing right there. That's the 9. So that means we could label each of these squares, right? These would be 8s right here. And that would wrap around the shape. And so the 9 height would be this one right here. Now you could put 9s all along here if you'd like. Not that you have to. But you'll notice that it creates rectangles that are all the same. It's just 6 of them, right? So if I said, hey, we want to find the area of all the rectangles, what you can do is just find the area of one and multiply it by 6. Or if you wanted to, you could say, I'm going to add all the 8s up. So that's 8 and 6, so that's 48 by 9 rectangle. And then you could find the area that way, okay? I'm going to go with what I said originally. So I'm going to find the area of one of those rectangles, which is a 9 by 8 rectangle. And 9 times 8 is 72. But we have 6 of those rectangles, so I'm going to multiply the 72 by 6. And yes, I do need a calculator for that. If you don't, then more power to you, man. 432 square units on this, okay? So that would be the full area. The 432 would be the full area of just the rectangle part, okay? So we need the area of the hexagon. And by the way, the 432 square units, that's the lateral area. All of those rectangles constitute the lateral area.
Are you doing the surface area?
So to find the surface area, let's kind of zoom in on this and figure out what the crap is going on. 6.9 is good. We know that. In fact, we know that this bottom part here is 8 units. Right. I'm using the wrong color. These are 8 units each, right? 8 and 8 and 8. Okay. Well, what we're going to do is we're going to split up this hexagon into smaller, more manageable shapes. Shapes that we're familiar with, like rectangles and, well, triangles, okay? Well, since they said this is from the center to the edge here, what we're going to do is we're going to make this a triangle right here, okay? And I can find the area of that triangle because I know that the base of that triangle is an 8 right there, okay? And also the height is 6.9. So if I said I want to find the area of that triangle, just the triangle part, I would take the 8, the base, and the height, 6.9. I'm going to multiply those. But we need to cut it in half, right? So I type this into my calculator, 8 times 6.9 divided by 2. And this rounds it for me. Oops. As the area is 27.6 square units. Well then, we just need to ask ourselves, how many of these are there? Well, that would be 1, the one that we found originally. There's 2, there's 3, 4, 5. I know some of you knew the answer before I started there, but 6. 6 of those. Yeah, now you could say there's 12. Now, I was looking at the full big triangle right here. So, it is possible that some of you cut that in half, right? You'd say, hey, look at this. It's half of 1. And you could say, you could find the area of that one right there. Yeah, so we do have the other hexagon, but I do want to find just the area of this one for now. So that's 27.6, but yeah, we need to multiply that by 6. So I go back to the calculator, 27.6 times 6 is 165.6. Again, that's square units. But again, there is 2 of these, so multiply that by 2, which gives us 331.2 square units. Now, that was a lot of work, and it was fun. Or I'm going to say that it was fun. But to find the total surface area, because we do have the lateral area, we need to take the lateral area and add the surface area of those 2 hexagons, which was 331.2. And whatever we get out of this will be the full surface area. Sometimes we'll just say SA. So what is that? A 2 and a 3 and a 6. Whoops. Decimal. 4 plus 3 is 7. 763 square units. That's what I'm going to say. Yeah, same with the 432. That would be in square units. As the lateral surface area. All right, now we got a pentagonal prism because we got the 2 pentagons on the top and bottom, so that's considered the base. And then we see all of the lateral faces are rectangles right there, which we would expect out of a prism. Now we do have the net on this one, and you can use the net if you'd like, but I'm actually going to proceed without the net because I believe on several of the assignment problems that there is no net as well, okay? So, well, without a net, what do? Well, essentially we're going to make a net, and we just kind of make it non-formally, right? Just informally. So, for example, I'd say, hey, look, we got the top there. It's a pentagon, which is good. And what do we know about that pentagon? Well, it shows this length from the middle of it to the edge. That's a 90-degree angle, and that's a 8.9 I guess it doesn't give the units on that. That's fine. But what do we do with that 8.9? Well, and we've seen that word. We'll see that word in not only today's classwork, but also in the assignment. That's called an apothem. An apothem goes from the center of a polygon to the outside at a 90-degree angle. And you could think, well, could it go right here? And then the answer is no, because then it wouldn't be at a 90-degree angle. So this is nice, because then it allows us to solve this, because we have one part of the triangle that we need, particularly in this case the height. And so the last thing we would need on this is the base value right here, which, since this is, it didn't say that this is a regular pentagon, but that's this length right here, which is 13. So all of these lengths around the pentagon are also 13, okay? 13 units, whatever that is. So if I wanted the area of just that one triangle right there, I'd have to take 13, multiply it by 8.9, and then divide that by 2. So let's go ahead and figure out what the area of one of those triangles is. And yeah, some of you know the shortcut at this point, what you would do to solve for the rest of that pentagon. Now when I put this in the calculator, it tells me the area of the triangle is at 57.85. That'd be square units, right? But we see that that's only one triangle out of 1, 2, 3, 4, 5 triangles. So I'm going to multiply this by 5, which will give me the area, the full area of one of these pentagons. So 57.85 times 5, and that's the area of one of the pentagons, 289.25. Now we acknowledge that there is a second pentagon on the bottom and the top, right? So we can multiply this by 2, and that will then give us the area of both pentagons. So multiplying by 2 then gives me 578.5. And this is the area of the pentagons, both pentagons together. Okay, so that's an important value. But now what I need is the area of each of the rectangles. So I would say, look, we got a rectangle right here. And in fact, since that's a 13 by, it looks like a 5 rectangle, they're all 13 by 5 rectangles. This rectangle right here is 13 by 5. Same with this one on the edge right there, 13 by 5. So we're looking at this rectangle over here. I took this one and then we moved it over here. It's a 13 by 5 rectangle. So I want the area of that one rectangle first, 13 times 5, which is 65 units. And how many of those do we got? Well, that's 1. Then we have this one on this side. That's 2, 3 here, 4, and then this fifth one, right? Which we would expect 5 rectangles because this is a pentagon. So I'm going to multiply that 65 by 5, put it in my calculator, and that tells me the area of all of the rectangles is 325. I'm going to label this one because it is one of the answers. That's the lateral area, 325 square units. But if I want the total surface area, I still need that 325 from the lateral surface area, but I also need the 578.5 square units from the two pentagons. So let's go ahead and add these together. So there's a 5 and 13, carry the 1, 903.5 square units. This was the total surface area. Okay. So, I mean, is it possible you could have drawn all 5 rectangles? You could have, but hopefully we understand that once you get one of those rectangles off the lateral faces, there's 5 of them, so you can just multiply it by 5 as well. So this one pretty much works the same way. It's another pentagon, right? Whether you use this net or not, you get a pentagon on the top and in the base as well. And I would like you to focus on doing this without the net. Okay, so I'm going to pause the video. Just take a minute and see if you can solve this one, all right? 1 minute, go. All right, hopefully that was enough time. Now this one I'm going to do a little different. Okay, again, I'm not using the net, but I see I got this rectangle right here. I'm going to start with the rectangles this time, which means that I'm going to solve for the lateral area first. Not that you have to. You can solve for the pentagons first, like we did in that last example. So we got this rectangle, something like this. And what are the dimensions of this rectangle? Well, it may be helpful to see this one right here a little bit more clearly. A 13 on the bottom and then an 8 on the side. It's a 13 by 8 rectangle. And we want the area of this rectangle, which is 8 times 13 at 104 square units. But again, how many of those rectangles are there? There's one in the front, this one on the side, 3, 4, 5 of those total. So again, I'm going to multiply that by 5, which is going to give me 520 square units. So that's actually our lateral surface area right there, 520 square units. That is our lateral surface area, or the area of the rectangles right there, right? But I still do need the area of the pentagon, at least one of them, because then I can find the other one. They should match, because this is a prism. So what do we get? We have an apothem, so that goes from the center to one of the edges at 90 degrees. That's important, because we are making a triangle out of this, just this part right here, right? And that apothem right there is 8.9 units. And again, we see that the base value here is 13 of that triangle. So let's go ahead and figure out the area of just that one triangle right here. I'll make it red. So just the area of one triangle, that'd be 8.9. And I multiply it by the base, but we do need to divide by 2. And I am showing this a little differently. So 8.9 times 13 and then divide by 2 gives me 57.85, which should look kind of familiar. And again, how many triangles will that make? Well, that's 1, 2, 3, 4, 5. 5 of those triangles. So I'm going to multiply this by 5. And that will tell me the area of one of those pentagons. It's 289.25. Of course, we do have 2 of those pentagons, so I'm going to multiply that by 2. And that will tell me the total area of the pentagon. So let's go and multiply that by 2 then to get 578.5 square units. And again, that's just from the pentagons right there. But I need to add that to the 520 square units from the lateral surface area. So 578.5, let's add that in. There's a 5 and an 8, 9, 1098.5. Again, that's in square units right there. And that would be the total surface area on this one. So, yeah, the top, we got this rectangle, and I don't know that that was better second time, but I'm going to keep this one. Those 2 rectangles are these 2 rectangles right here. Okay, so that's what makes it a rectangular prism. And you could say, well, couldn't I rotate this and make it different? Yes, you could. But the way that this net is drawn, we're just going to keep with what it says, which means that this part right here is the lateral area. Okay, so that, again, that's the rectangles that wrap around this shape. Well, let's go ahead and see if we can figure out where these measurements go. All right, now this 15 right here, it's kind of the height of this rectangular prism. That would go right here. And it's true that it's also these lengths as well, and we are going to need those. Okay, we do have the 5. That's kind of the width or depth of this prism. That would be this length right here, these ones right here. Those are fibers. In fact, you got these ones as well. Those are also 5 right there. Okay? And then what do we got? I put 16. I meant that's 15 right there. Copying's hard. The 16, this one right here, we'll make that 16. That would be this length. I guess I already got it in green. That's 16. 16 and then 5, okay? Now it would be nice to figure out the area of this rectangle, and since we have all the measurements we need to find the area, we can figure that out, right? we can say this whole length here on the bottom, just add these values together. 16 plus 5 plus 16 plus 5 is 42. So the area, just, again, this is the lateral area, so usually they just write it as LA. It's a 15 by 42 rectangle, all right? So I put this into the calculator, 15 times 42, length times width, base times height, however you want to look at it, and you got 630. I'm gonna label this in square units, and since this is one of our answers, right, and wanted the lateral and surface area, I'm gonna label this. So 630 square units, that's the lateral area. Okay. Now that helps us to find the total surface area because I have these two rectangles on the top and bottom. Okay. And yeah, this is a 16 by 5 rectangle, just from what we see on the bottom, right? These two measurements. So the area of one of them would be 16 times 5. It's a 16 by 5 rectangle. 16 times 5 is 80. But we got two of them. They're the exact same rectangle. So I just multiply this by 2, 160. And that's the area of the base rectangles, both of them. So I just need to add that to the 630. And what do we get? 0, 9, and 790 square units. So this would be the total surface area. I'm just going to write SA, surface area. Total surface area if you want. And that's the two answers we need on this. Let's get these measurements down first, and we can see just at here at the bottom, that's a radius right there, right? Because it goes from the center to the outside of that circle. There's 2, so we need to put that on these circles. See if we can zoom in right here. We'll come back to it. That means this length right here is 2 units, we'll say. And then the other measurement, there's all the measurements we need to solve this one, is this 10 right here. Well, that's the height of this cylinder. So that would be this length here on, I'm going to put on the right 10 right there. I mean, if you prefer to see it over here, that's fine too. And in fact, we can go to the other circle and make that, show that that radius is also 2. Maybe that helps. Okay. Now I'm going to start with the circles on this. Okay, and I don't really need the drawing anymore. So I want to find the area of the circle, just one circle first. So we know that's pi times radius, and right now the radius is 2. And that is a full circle, so it's just pi times 2 times 2 times 2. And now again, it gives me 4 pi. I just push the double arrow on that, and it gives me a 12.56. I'll go to the thousandths on this one, 566. Which means the area of this circle is also, without needing to calculate, 12.566. Again, that being square units. But what about this rectangle right here, which is also the lateral area? So the lateral surface area is nice because it is rectangle. And by the way, hopefully this makes sense to you. If you were to take this shape, all we're going to do is we would just wrap it around the circle in order to make that lateral part of the cylinder, okay? But finding this length right here, the other length, right, we know the height here is 10, or the width, if you will. Length times width of this rectangle is the area. But finding this length is a little bit more complicated than just length times width, because this whole length right here is going to go around this circle, right? Well, if because it has to go around the circle, which is true, then the length that I have in green there is the actual circumference of the circle. So I actually just need to find that one, the circumference of the circle. That's pi times 2 times the radius, but we do know the radius, which is 2. And, excuse me, sure enough, we found that already, 12.566. So that means this length right here is 12.566 units, okay? So if I wanted the area of the full lateral area, this area of this rectangle is the 12.566 multiplied by the 10, which is 125.66. And again, that's in square units. So that's our lateral area right there. In fact, I can put LA right there, lateral area. But I do want the full area, right? So I can take the 125.66, whoops, put a 0 there. And then we need to add 12.566. If you already multiplied it by 2, then you just add that. But I'm showing all three areas right here, right? You have the area of this circle in red, and then the lateral area there in orange. We just need to add those together. So 125.66 plus 12.566, two of those. And this is what I get for my total surface area. 3,000, whoa, that's that seems a little big. Let's try that again. 125.66 plus 12.5, oh, I did times. That's not good. Here we go, 150.792. Again, this is in square units. And that would be the total surface area here. Okay, so we did find both of those. It was very nice. All right, number 13, we got a hexagonal prism 6 feet tall with a regular base. So the regular base indicates that all the lengths of the hexagon are the same length. So let's see, 9 feet on each edge of that hexagon. So let me start with the hexagon actually, and I'll try to do this three-dimensional as best I can. So there's a hexagon. I don't know how regular it is, but I think it'll work. Six-sided shape for a hexagon. So let's go and just pile this up like that. And again, this is the start of our hexagonal prism. So yeah, all we got to do now is just connect the edges together. And I guess I am kind of leaving a little space right there so that we can tell the difference of the two sides that we're looking at. Six-sided figure. And then, of course, we need to see if I can clean that up just a little bit. There we go. That's not my worst work right there. And that sets up our hexagonal prism right here. And let's go ahead and start measuring or putting down some of these measurements. So we know it's 6 feet tall. Well, that would be the height right here. It's 6 feet. And of course, that's all of the heights along the edges, which is going to help us with the lateral surface area. And then each of the lengths of the edges of the hexagonal prism is 9 feet. So that would be all of these that make up the hexagon. So this is a 9-foot edge right there. And then we have an apothem at 7.8 feet. So that, again, that goes from the center to the edge at 90 degrees. Okay? Well, that length is 7.8 feet along there. Okay? So having drawn this, then hopefully this will help us to kind of figure out the rest of it. If I'm looking at a hexagon six-sided shape like this, we can put the apothem on this at 7.8 feet. And again, we do know that each of the edges is at 9 feet like this. Okay. So when I want to figure out the triangle, which I do need, the area of one of them, of course there will be 6 total triangles, all matching. And this would match if I had drawn that a little better, of course. But I need to find the area of just one of those triangles. So that would be like taking the height, that's 7.8 feet, multiplying it by 9. And again, we just need to divide that by 2. Again, I showed that a little different. I hope that's okay. 7.8 times 9 divided by 2. And I get that the area of one of those triangles is 35.1 square feet. Of course, there's 6 of those triangles there, so I need to multiply that by 6 to get 210.6 square feet. And again, that's just one of these hexagons. We do have 2 of them, though. So I do need to multiply that by 2. And that gives me 421.2 square feet. That would be the area of both of the hexagons. Okay? So that's a really good start right there. Now, the other shape that we have is the rectangles. Okay? So something like this. And I'm trying to color coordinate these so that we know that purple is 6 feet and then the red is 9 feet right there. We do want the area of that full rectangle. So the area of that rectangle would be 6 times 9. Well, that's just 54 square feet. And how many of those rectangles are there? well, there's 6 going all the way around. I got 1, 2, 3, 4, 5, and then 6 right there. Okay? So we need to multiply the 54 by 6. That will give us the lateral surface area, by the way, which is 324 square units. That's a Q, square units. So that's our lateral area. And that would be one of the answers for the assignment. But we need to add the 421.2 square units to figure out the total surface area. So the final total surface area, 324 plus 421.2, and I get 745.2. Again, that's in square units. Not units, I apologize. This is in feet, right? We do know the units on this one. Square feet. So yeah, the lateral surface area also in square feet. And that completes the problem.